Today I'm going to do a short presentation on the precast box cover design and selection. So a short introduction on myself. I'm a technical service engineer from Hynds Pipe Systems, and I have 8 years experience in the engineering and construction industry overseas and New Zealand. I'm specializing in the design and manufacture of precast products, including box covers, chambers, channels, retaining walls, etc. So I have designed and delivered numerous projects across New Zealand for complex engineering conditions such as high seismic and special geometry of box covers. So we'll have a look at an overview of this seminar today. First of all, I will go through the background of this seminar, and I will introduce some design principles regarding box cover design, such as related design standards, design loading type, and seismic design approach. Lastly, I will introduce a few tips on box cover selection to choose your perfect box cover for the project. So before I make a formal start on my content of today's seminar, I would like to introduce Andrew's CPD webinar on precast concrete. Andrew introduced his experience on delivering precast projects and gave insightful ideas in these seminars. You might find them very helpful, no matter you are a civil or structural engineer, or regardless of your design experience. So go to the YouTube channel, you can find these videos with the same title name. All right. So let me start by introducing a bit of background of this seminar. So as you might have already known, there are several typical applications of box culverts, such as stormwater box culverts, pedestrian or on the cattle underpass, or when you put two plugs onto the box culvert, they become a storage tank. So on the screen, on the left-hand side, you see a cycleway underpass made of box culvert located in Hamilton. And on the right-hand side, you can see a storage tank located in Nelson made of box cover mold. So during the design and delivery stage of these box cover units, we often received inquiries from the contractor or the design engineers from consultancy. They will be asking what the load is the box cover designed to, or what environment can the box cover be used, or how deep can it be buried. So with these questions, we'll go through the design principle and selection of box covers in this seminar today, and we'll find some answers for them. So box cover design, first thing is design standards and codes. So there are several design codes that are commonly used in the engineering and construction industry and will be applied to the box cover design as well. So first of all is the NZS 3101 concrete structure standard, which I assume it is familiar to most of our structural engineers. NZS 1170 structure design actions, 3109 concrete structures, which is used for the manufacturing of box covers. And lastly, the NZTA bridge manual. And in today's seminar, I'll introduce an example based on NZTA bridge manual to give you some short pictures on the design loading we'll be using for box cover design. Box cover design example. So we are looking at a stormwater box culvert of a size of 2,500 in width and 2,000 mil in height. So the soil cover over the box cover ranging from 300 mil to 1,000 mil, and design load is HNHO72 loading with the traffic perpendicular to the water flow or the longitudinal direction of the box culvert. So for those of you who are not familiar with the HNHO72 loading, we're going to do a quick introduction on them in this seminar. And also there's an assumption on the box culvert design as well as external and internal water pressure is balanced, or you can say the underground water table is below the base of the box culvert. In this case, we don't need to consider the additional water pressure or imbalanced water pressure acting on the box culvert. Now we are looking at the load spread diagram acting on your box culvert. So on the top, you can see a tire footprint that represents a wheel of a vehicle. There's a certain depth of the soil cover above the box culvert, and you will see in this case there is no load spread because the soil cover H is less than 400 mil. We will dig into this by introducing the HNHO72 traffic load, which is defined as in the NZTA bridge manual. So on the right-hand side, you will see the diagram of the HN loading and HO loading elements. The two circles representing the wheels of the vehicle, and the 4 points are how the contact load is laid out in the bridge deck. So for HN loading, the N means normal. The point load is a 60 kilonewton wheel load, or equivalent to a 120 kilonewton axle load. The full tire footprint will be 500 by 200 mil, with 500 mil on the horizontal direction and the 200 mil along the traveling direction of the vehicle. 1800 mil is a tire spacing in HN loading, and 500 mil axle spacing along the direction of a vehicle traveling. There's a 3.5 kilonewton per square meter UDL applied on the bridge deck. Also, your box cover top slab. And for HO loading, the O represents overload. It consists of a 120 kilonewton wheel load or 240 kilonewton axle load. The tire footprint will be larger, 900 mil by 600 mil, and it has a 2100 mil tire spacing along the axle and the same axle spacing along the vehicle of 5,000 mil. It also has 3.5 kilonewton per square meter UDL acting on the deck of the box cover. So we're looking to these low spread cases one by one. First of all, this is a case where your soil cover over box cover is less than 400 mil. As required in bridge manual, in this case, the wheel load doesn't have a low spread. So it will be acting directly with the tire footprint, the size of tire footprint on the box cover top slab as a moving, like partially UDL load. If that's a case of HN load, it will be a 500 by 200 mil area of UDL load. And the second case is when your soil cover is getting deeper, you will have some some kind of load spread of the wheel load acting on the box culvert. It consists of two parts. With the shallow part of the soil, within the shallow part of the soil, you will have a shorter load spread, which has a 1/0.5 slope. And as it goes deeper, you will have a 1/1.2 slope. This is as described in the bridge menu. And in this case, you will have a larger load spread, which might reduce the actions you are going to design to for your box culvert. The third case, so when it goes further deeper on the soil cover depth, you will have a case where your two wheels might have overlapped load spread. In this case is when your soil cover H is larger than the wheel spacing on the same axle. So in this case, we need to consider the UDL as a result of the total combined wheel load divided by the area of the overlapped load spread. In this case, we get the final design UDL on your box cover deck. So that was load spread acting on the box culverts. So now we'll look at how to calculate the final actions and capacity demand on your box culvert. So first of all, that is a vertical load components. At traffic load, as we described before, it's made of one wheel load with or without load spread, and second component is live load with the general UDL all across the box cover deck. The dead load component for vertical load is a soil and concrete self-weight acting on the top slab of the box culvert with us related to the depth of the soil cover H. Then we'll look at the lateral load. So first component is lateral earth pressure, which is part of the dead load. It is calculated by gamma times K naught times H, which is the depth from the ground level to the bottom of the box culvert. And the live load component will be K naught times the live load UDL on either side of a box culvert. So live load will be in this case, we'll be using a global analysis live load, which is 12 kPa equivalent to HN or 24 kPa equivalent to HO. So bear in mind, we're going to use K naught, which is at rest pressure, at rest lateral earth pressure coefficient for the calculations of the lateral load. Because we consider the walls of box culvert as rigid wall other than a flexible wall. In the end, by combining all the dead loads and live loads acting on the box culvert, we'll get the static case bending moment diagram of the box culvert, which is as shown on the screen. So from there, we need to detail the box culvert reinforcing at the critical sections to cater for the design actions. So we need to specify reinforcing at the midspan of the top slab and base slab, and also on the external face, such as a corner and midspan of your box culvert. Next, we will have a look at the durability design. So this is a general section as per NZS 311. Exposure classification. We can design the box cover to various of environment most commonly seen as B2 exposure classification. Design life, we can design to 50 years or 100 years. Concrete cover, it is subject to the exposure classification and the concrete strength that you're using. Depending on whether you're designing this the box cover structure to a severe environment or not, you might need supplementary cementitious material for your concrete mix. So we have a reinforcing detailed for your box cover in the end. So this is a typical reinforcing layout for the box covers. As you can see on the external face, we have one layer of reinforcing and another layer on the internal face. Some chamfer bars at the corners, longitudinal bars running through the cover unit along the travel or the water flow direction or the longitudinal direction of the box cover line. Right. After we talk about the static case of a box cover design, we'll have a look at the seismic design actions of the box cover. So first of all, I will calculate the elastic side hazard spectrum for horizontal loading for the box covers, which is also namely the PGA of the structure. So we'll calculate that based on NZS 1170.5 with the formula on the screen, which I assume is very familiar to most of you guys. We have a quick look at these factors in the formula. The spectral shape factor decided by your size subsoil class and the period of structure. The Z factor decided by the location of the project. Return period factor decided by the importance level and design life of the structure. And lastly, you pick up the near fault factors, which is defined by the location and the importance level of the structure. Sorry, just one more quick thing. Just to be noticed, just to be noticed that there's a coming up technical specification draft of NZS 1170.5. Yeah, coming up, and that now is pending for comment. New Zealand Engineering News Standard New Zealand is running updates on the design code of seismic design actions. So the indication is that the design PGA might be higher than the current values defined in 1170.5. So that can be one part we need to take into consideration of the design of box covered going forward. So we have a look at the sectional design in terms of seismic for the box covered. According to Bridge Manual, there are three principal types of deformation on a tunnel project, which are axial, curvature, and racking. So the axial and curvature develop along the longitudinal axis of the box culvert. And in this case, given that we are considering the box culvert are flexible units along the longitudinal axis, so we don't need to take the actual deformation and curvature into consideration. We only take a look at the racking analysis based on the earthquake loading. So on the left-hand side, you will see a diagram of racking deformation of box culverts under shear wave which is horizontal or perpendicular to the box cover line. In that case, you will see assumed single barrel box frame model based on the racking analysis, where you see a point load P at the top of the box culvert, and which causing a displacement of delta of the top slab. So there are several steps of racking analysis of a buried box culvert. So we'll need to do that by evaluating the following parameters. A is free field peak shear strain in the soil, which is related to the the soil parameters and the peak ground accelerations. And the second one is elastic and post-elastic stiffness of the structure, which is related to the geometry, sectional size, and reinforcing content of the structure. And the third one is racking deformation of the structure, which can be calculated or picked up from a diagram, a graph based on the peak shear strain calculation. And the last one is a member force in the structure from the racking deformation, which is your bending moments and the shear forces. So I won't be going into details covering this topic in this seminar here, but for those of you who are interested in this topic, you can go through this paper by John H. Wood, Earthquake Design Procedures for Rectangular Underground Structures. There are details, including examples on how to work out the racking analysis of a buried box culvert. So eventually, after the racking analysis, we'll get a bending moment diagram as shown on the screen. You might notice that the bending moment will appear at the internal face, internal corner, and external corner of the box culvert. So we will need to detail the reinforcing to cater for those bending moments at these locations of the box culvert. So that was the static case loading and the seismic case loading for a box cover design. So we'll go through a checklist of designing a box culvert. So that will include the application of the box culvert, which which decides the exposure classification and the design life of your project. Design traffic loading type. As we have mentioned, it can be designed to HNHO 72 loading, or in some cases, it could be a construction loading or other specific loading we need to look into. Soil cover depth, it will affect your load spread of live load on the box culvert, and it will affect the seismic design parameters of your box culvert. Subsoil classification, that's related to seismic. Importance level structure related to seismic as well. So lastly, location of a project that governs all the seismic design and your exposure classification, durability design as well. All right. With the design principles being talked about, we'll have a look on the practical side of choosing a box culvert for your project. So as we know, the box culvert, the precast box culvert are costing different kinds of modes. So after we confirm design parameters, ideally we would want the box culverts to be made in existing modes from your manufacturer. This is to reduce the lead time and cost on your project, so you don't have to procure a new mode and for the box culvert, which will extend your lead time and cost. Typically, if we look at the standard box cover sizes from Hynds, there's a 500 mil increment of the box covers. So you will see that if you are choosing a 1500 by 1500 box covered and you want to make it larger, you can go to a 2000 mil by 2000 or 2000 by 1500. Yeah, and you might also consider using an alternative size combined for larger spans. Say if you are after a 6 by 3 meters box covered, which is 6 meters represent the span, and you can replace the selection of box covered with a dual line of 3 by 3 box covers, which enables you to have a smaller self-weight on the box covered, easier for handling and lifting, and possibly lower cost as well. So lastly, we need to consider the weight limit for lifting and transportation, which is what equipment like the cranes you have on the construction site, how much you can handle with those cranes and that will be the basis where we need to start off to choose your box covered. Yeah, thank you everyone. So with this seminar, we talk about the general design principles of box covered and some tips on selecting the perfect box cover for your project. And I hope that is useful to your box cover project. Thank you.
So thank you very much, Wei Dai. That was a guest presentation for a change. And why did we do it? Because he asked. And so if anybody else wants to do a guest presentation, courtesy of me, and get their work put up onto our YouTube channel, then let me know. So if you've not seen the other seminars, and this is where today's seminar will end up, if you go onto YouTube, you can do a general search on Daddy Pig 6354, or even just the titles are now popping up. So I must be having some impact on YouTube now. Under the playlists, there are 3 playlists you can see there. One's for deep thinkers. One are snippets of MathCAD. So they range from 5 to 10 minutes. Extracts of actually going through the MathCAD, and this is the one where all the CPD webinars are. I say all, most of them are, from number 2 right through down to 21, and that was my last one a couple of weeks ago. So please subscribe to the channel, share the show with your friends, and leave a like, leave a comment, and even suggestions for future webinars.